Let's start with going over and reviewing the exponent rules that we've learned before or that might be new to you guys. So the first rule that we are going to learn is when we're multiplying. So when we are multiplying, we're going to keep the base or the variable. If you've learned it by that term, they are synonymous, and we're going to add the exponents. So in this case, it's going to look something like this. I'm going to have my base or my variable of x to the nth power times x to the nth power, and the result of that is x to the m plus nth exponent or power. As an example, x to the 5th times x squared is going to be x to the 7th following that rule. And we can explain it by this. Think about x to the 5th as really x times x times x times x times x. And x squared is really x times x. So when we do x to the 5th times x squared, what we get is x times x times x times x times x times x, or x to the 7th. And that's a way that you can remember this rule. So you're going to keep that base or that variable, and you're going to add the exponents. So the next rule we're going to work with is when we're dividing our variables that have exponents. So when you're dividing, you're going to keep the base, but this time instead of adding, we're going to subtract the exponent. So the rule is basically, in this case, x to the m over x to the n is equivalent to x to the m minus n. So let's do an example just so you make sure you got it. X to the 5th over x squared is equal to x to the 5th minus 2, 5 minus 2, which is x to the 3rd. Again, that is because our x to the 5th is equivalent to the product of 5 x's. Our x squared is the product of 2 x's. So if we think about what x to the 5th over x squared is, it's really the product of 5 x's over the product of 2 x's. And you can see that this x here, because it's a product, will cancel this one out. This one will cancel this one out, and we're left with 3 x's, or x to the 3rd. Now we're going to figure out what we do when we have a negative exponent that appears, because we don't want to leave the next negative exponent in these simplified forms on our homework. So the rule for dealing with negative exponents is that we're going to find the reciprocal and remove the sign of the exponent. An easier way to remember this is we're going to flip our base over the fraction line, and we're going to change the sign of the exponent. I should note that in there, and I will, because we need to make sure that the flipping is happening with the variable and the changing of the sign is happening with the exponent. Let me do an example. So x to the negative mth power is equal to 1 over x to the mth power. And if I had 1 over x to the negative mth power, that equals x to the mth power. Remember, x to the negative mth power is a fraction. It's just over 1. So you can see that it's the reciprocal of that. We've actually just flipped or found the reciprocal of the fraction and then removed the sign of the exponent. As an example, let's go back and do a division problem. Remember, our properties for division are that we're going to subtract our exponents and keep our base. So x squared over x to the 5th using our rule is x squared minus 5, which is x to the negative 3rd power. So I need to find the reciprocal or flip that. So I get the fraction of 1 over x to the 3rd because I can remove that sign. And the reasoning for that is, again, we have x to the 5th is the product of 5 x's. X squared is the product of 2 x's. So when we have x squared over x to the 5th, we get the product of 2 x's over the product of 5 x's. Now we cancel out this x with this x with this one, because they're products. So we get 1 over the product of 3 x's, or 1 over x cubed. So for our last exponent rule, we're going to do what we call the power of a power rule, which we keep the base, or we keep our variable, and we multiply the exponents. What that rule states is that if we have a power being taken to another power, so in this case, m is being taken to the power of n, or the entire contents of inside this parentheses is being taken to the nth power, or is the product n times. The rule is that we take x to the m times n. So we multiply the exponents in this case. Let's do an example. So in this case, we have x squared, and we're taking that to the 5th power. So the result based on the rule is x to the 2 times 5, or x to the 10th power. The reason for that is this is telling us to take the content in this parentheses x squared to the 5th power. So that's equal to x squared times x squared times x squared times x squared times x squared. So the product of 5x squareds, which we learned in our very first rule when we have the same base and we're multiplying, we add our exponents. So it's x to the 2 plus 2 plus 2 plus 2 plus 2, or x to the 10th power. Likewise, if we had x to the 5th squared, that's the same thing as squaring the contents, or squaring x to the 5th. So x to the 5th times x to the 5th. Again, using our product rule, we have x to the 5 plus 5, or x to the 10th power. Just to note, this is not the same thing if we have an addition sign within our parentheses. So if we are squaring or taking something like x plus 5 to the 2nd power, we're multiplying x plus 5 times x plus 5, which is binomial multiplication, which you guys have learned various methods for, and we can talk about. That isn't part of this assignment, but if you don't know how to perform this, let me know, we can talk about it. But this is not the same thing as this power of a power rule. So what we're going to do next is I'm going to do an example of a few of your homework problems, just so we make sure you're okay to finish the homework.